Welcome to lesson 7.7, writing and applying quadratic functions. So, we are going to take a whole bunch of random bits of information that people might give us and write equations that follow those rules. So, I'd like to point out for you this little word here. Find a quadratic equation with integral coefficients. So, because that's not the word the, and instead it's just the word a, this is giving you the signal that there might be more than one correct answer. So we're going to keep that in mind as we work through these problems. So for our first example, we are looking for an equation when we're given the roots. So the definition of a root of an equation is an x value that makes y equal to 0. And you might say, well, isn't that just an x-intercept? Well, it turns out that roots don't have to be real numbers. X-intercepts do have to be real numbers, but roots do not have to be real numbers. And that's why we're using this vocabulary. So we're going to treat these like x-intercepts. And we're going to use our factored form. So I'm going to start with my equation, y equals a, x minus the first root, x minus the second root. So in this case, I have roots of 2 plus root 7 and 2 minus root 7. So I need to subtract off the whole 2 plus root 7 quantity, and I have to subtract off the whole 2 minus root 7 quantity. So let's distribute that negative. And I get this formula. Now, this doesn't look like a pile of integers, so we are going to have to multiply this out. And you can do that by multiplying all the parts of the first one times all the parts of the second one. But there's a little bit of a shortcut here, which is that if I break it up in this way, I have x minus 2 as the first part, and either plus or minus root 7 as the second part. So this is, as Dr. Babinet would say, best friends, and we can write this as a difference of squares to save ourselves some work. So I'm going to start with x minus 2 squared, which is x squared minus 4x plus 4, minus, because it's a difference of squares, root 7 times root 7 is 7. So what I've found, if I just combine like terms, is that I get some number times x squared minus 4x minus 3. So I don't want to leave a in my formula. I want to pick an a value that's actually going to work. So remember, there's more than one correct answer here. And in this case, because all the numbers in front of the variables here are already integers, right? We wanted integers. I can just let a be 1. And if I let a be 1, I will get this final answer. But it would also be correct to write 2x squared minus 8x minus 6, or to write negative x squared plus 4x plus 3, because all of those equations will still have these two roots and will still have all integers as their coefficients. So let's try part B. Again, since I'm given roots, I'm going to start with this factored form. So some number times x minus the first root, 4 plus 2i, times x minus the second root, 4 minus 2i. Again, I will distribute inside the parentheses. And again, I see that I can write this as a difference of squares. X minus 4, quantity squared, will be x squared minus 8x plus 16. Then I need to subtract 2i, quantity squared, which is going to be 4i squared. Remember that minus 4i squared is the same as plus 4. So, combining like terms, I will get this formula. And again, all of the numbers inside were already integer coefficients. So I'm just going to let my a be 1. But it didn't have to be 1. If I picked a to be 10, I'd get 10x squared minus 80x plus 200, which would also be a correct answer. So let's move on to part C, number 2. So one of the differences here, we're still looking for a quadratic equation, but now we're not told that we need to have these coefficients be integers, but we are given some more information. So let's talk about what it means for a quadratic to have a maximum value. So what that means, if I draw a little graph here, is that whatever parabola this is has to point down, or it wouldn't have a maximum value, and that maximum value is up at 6. So this is really telling me that the vertex of my formula has a y value of 6. So let's collect that into some usable information. So I know from the problem that the vertex has a y of 6. And that's only going to be helpful if I also know the x value of the vertex. But I can find that from my x-intercepts, because if I want to know the x of the vertex, I can average the x-intercepts. So I'm going to put -2 plus 4 all divided by 2. -2 plus 4 is 2, divided by 2 is 1. So that gives me a vertex of 1, 6. And I also have some other information. I'm given x-intercepts, which means that I have two other points, -2, 0, and 4, 0. So from here I have a choice. I can use this factored form because I know my x-intercepts, or I can use vertex form because I know the vertex. Since we've just done 2 examples with factored form, I'm going to use vertex form so that we get more practice with that one. So in general, vertex form looks like a times x minus h squared, don't forget the square or it won't be a parabola, plus k. And in this case, my h is 1 squared plus my k is 6. And we need to actually find what a is because we are given more points. So I'm going to pick the one that doesn't have any negatives in it to plug in. So my y value is 0. My x value is 4. So if I subtract 6, 4 minus 1 is 3, squared is 9. Divide by 9 on both sides. And I find that my a value is -2/3. So that's going to give me a final answer here of y equals -2/3 x minus 1 squared plus 6. And unless the directions in your problem tell you otherwise, you can leave it in whatever form you used to find it. So let's do one more example. And this one is a real world example. A rectangular pen is made with 100 meters of fencing on 3 sides, and the 4th side is a stone wall. So if there's my wall, then I'm going to be putting fence around 3 sides to make a rectangle. And my goal here is to find the greatest possible area. So the maximum area. Well, if I want to find the maximum area, I will need a formula for area. And right now, I don't know any of the dimensions of this shape. So let me throw some variables down so that we can write an equation. So if I want to know what is the area, well, that's just going to be x times y. But this isn't helpful yet because I don't know how to deal with formulas that have 2 variables over here on this side. And if I divided by 1, I'd end up with 2 variables on the other side. So I need to do something else to decrease the number of variables. And the big thing we need to use is this 100 meters. So what is that 100? That is the perimeter, not of the whole shape, but just of the fence part of it. So 100 is going to be 2 x's plus a y. And from here, I can solve for y to decrease the number of variables here by substitution. So I'm going to take this and plug it in to my area function. So let's multiply that out. And I'm also going to rearrange it into the order that I'm used to seeing it. So what is this telling me? Let's look at this -2. So because my a value is negative, that means that this parabola, whatever it is going to be pointing down. And my y value isn't really y, it's a. And my x value isn't really, or actually is x in this case. So if I want to find the biggest area, the highest up this goes, that maximum is going to happen at the vertex of this parabola. So let's calculate the vertex. So I'm going to get -b, which is -100, over 2a. So that'll be 100 over 4, also known as 25. But I wasn't asked for x, I was asked for the maximum area. Well, that's going to happen if I just plug in to find my a. So max area when x equals 25. So that maximum area is going to be, and I'm going to plug it into this factored form because I think it's going to be easier, 25 times 100 minus 2 times 25, which is 25 times, well, 2 times 25 is 50, 100 minus 50 is 50, which is going to give me 1,250 with some units. The area, the lengths are meters, so the area will be meters squared.